Welcome to class. Today's MEP discussion is going to start into HVAC. And before we get too far into the equipment, we're going to try and just introduce some terms and high overview here. So we're going to be in PowerPoint in this lecture, and it shouldn't take too long. So let's get into it. So today's topic, you can see the lists there, and comfort, temperature, humidity, circulation, filtration. Maybe these ideas are new to you. Ventilation, maybe they're not. But as I like to do, I'm gonna try and over communicate a bit. So let's define some of those things and what we're trying to accomplish with our HVAC system. So we've got a couple diagrams here. The upper one being typical residential type systems that work together. And remember, hopefully you remember the idea of a schematic and systems, and so there's a bunch of components working together to try and create an effect, or in this case, comfort. So, and the idea of some of these providing circulation, some are providing filtration, dehumidification or humidification, temperature, ventilation or filtration, right? Or I kind of got that one twice, sorry. And then kind of the same basic thing, but different equipment on a commercial building. And the equipment varies so much that it's impossible for me. Maybe that impossible is not the right word. That's an absolute, but it would take a lot of effort on my part, more than I have time right now to dedicate to it, to learn all the different types of equipment or all about it. But I have a pretty good general idea about the equipment and how it all works. But all I'm saying is that there's a lot to it, and it can be overwhelming when you're on different projects and they're using different kinds of equipment. It's not the same as the one before. If you can get to the principles of it, then it's not too hard to understand. And this is some of the principles that you need to understand, that we're trying to circulate air, we're trying to filtrate air, maybe dehumidify air or provide humidity back into the air, providing heating or cooling through the temperature controls, and we're providing ventilation. Those are the basic principles, right? And I think it might be obvious to state, but you're in a building where there's a lot of humidity. Too much humidity doesn't feel comfortable. And I don't know if it needs to go much more than that, is that the house is too hot, it's not comfortable. And generally, there's kind of a narrow band of temperatures that people feel comfortable in a building. Obviously, it's not a fine range, but there's a general range of temperatures and humidities, and amount of filtration and new air need to be in order to be comfortable. So let's get into the two heating and air conditioning equipment on just some ideas here on general systems. So we have a furnace showing here with an air conditioning unit, condensing unit. So this would be outside. This would be typically in a single family home. You'd see the furnace in the mechanical room, wherever it might be. Maybe it's in the ceiling or in the attic space, but the air conditioner condenser unit would always be outside. On a large commercial project, especially when we're talking about, as we've used in the past, the classroom setting in that building where your classroom is, it's definitely on this magnitude where you're having some pretty large boilers or some large chillers, and that's providing heating and cooling. And so let's just keep going into some more ideas here. Humidifier, dehumidifier. And so really we're just talking about humidity and what can add water to the air or remove water from the air. Water might not be the right word, but we're talking about humidity. So it's a evaporated water in the air, right? So the Utah's doesn't have a lot of humidity, so a lot of the homes and commercial buildings are adding humidity to the space, where in other locations it's more comfortable to remove quite a bit of the humidity, and that's more comfortable. And lots of different ways to do it. We're going to get into more detail there. And so a relative humidity range of about 50%, which means 50% saturated, is about normal. I don't know that that matters a lot, but maybe it's good to know. Okay, concept of circulation. So if you're in a room or a building or something like that that's poorly circulated, doesn't have a lot of air circulation, you can get different compartmentalization of heating zones, right? So you could have like all the hot air up at the top, and anyway, but the point being, stagnant air is not comfortable. So when HVAC is trying to be designed, the maybe go into this first. So it's not just the temperature and stuff that gets stagnant, but think of like the CO2 or the amount of oxygen, or um, I already kind of talked about the hot and cold air being separated a little bit more, but it's more than just the heat in the air being compartmentalized. So when you look at the idea of a basic home here and how it's supposed to function, is you have a furnace and a blower, and it's blowing air, and typically you want that to be coming into the space near the outside wall, and then it can be configured however you want, but in general the air is going to be ducted from the furnace to the outside wall and then get pulled back into the return ductwork, and then back to the the furnace, and the blower's doing all that. The blower's both acting as positive pressure on this side and negative pressure on this side to be able to push air and then create the negative pressure to be able to pull air into that return air. And just kind of a general idea here that the air needs to go towards the outside of the building and come back in towards. So lots of rooms. If you go in your room, try and figure out where the different parts of your home, where the registers are versus where the grills are, and register being a supply, grill being the return, and feel which direction the air is coming out. So you should be feeling air coming out towards the wall side and air going back in more towards the center of the home. Okay, now I think this is again pretty common knowledge, but there is filtration that happens on HVAC systems, whether it's a very simple furnace right here on the residential side, and it's just got a very simple filter that could slide in and out to be replaced as needed, and it's catching airborne particulates, so it's picking out dust, all kinds of pollen and little particles, right? So it's just trying to clean the air before it gets pushed back into the supply side. And so that's the idea if we're going to filter the air. There's another idea here in a second we'll share more, but on a commercial side where maybe this is a bigger system, still the same idea. Lots of different configurations for filters. The actual size and efficiency of pulling out the particulates or the contaminants, that ranges quite a bit. You could have like a HEPA system that is supposed to be pulling out super small particles, and then you could be something just kind of industrial, just trying to pick up like sawdust or something like that. Or anyway, there's all kinds of different filters and the different needs to meet your needs, but you need to understand the idea of filtering. So there's another way to try and reduce, I don't know if you want to call it particulates, but it would be odors. And the idea behind odor removal is to put filtered air into the space and exhaust the air that has odor. So in a typical bathroom, restroom environment they have, think that's an easy place to understand. They have an exhaust fan, and that exhaust is just pulling air out of the space and dumping it into the outside. And it's a pretty straight, simple system, right? It's just either on and off with the switch, or it could be on a commercial building. It could be on and off with on a timer. It could be on and off with a motion sensor. It could be anything really. But then it can get really complicated on trying to what you're going to do with that ventilated air. Maybe you're going to try and do some heat recovery with it. We'll talk more about that later. So if we're going to take air out of a space to remove the air odors, and also think of like the CO2 buildup. If you had a really tight room, eventually the oxygen levels would go down, the CO2 levels would go up. Now I'm wondering if it's CO2 or CO, carbon monoxide. Anyway, in the middle of a lecture right here, probably shouldn't be second guessing myself, but I'm thinking it's CO, not CO2. But the point being, we'd need fresh air. So the term that we're looking for there, as we try and exhaust air, is to make up air. Let's see if we've got this idea here. They're trying to, we have some outside air coming in to this commercial space at 20 cubic feet per person. You got a little damper here, and it's going to the blower, and then you got some coils or whatever it might be, humidifier, and it's going out to this building space through a register, and then it's coming back in, and some of it gets returned back into the loop, right? You see how some of the air is following this pattern? Well, some of the air is getting exhausted at the same time. And this is this pattern right here is specific to a specific type of equipment that you can have. But the point being that some of the air gets recirculated and some of the air is new from the outside. And what do you need new air for? Well, if you exhaust air, then you need new air. You also need to get rid of the so that's from like the exhaust of like could be exhausting like a restroom. You need to put more air into that space. And so that's one idea. We already went through carbon monoxide and oxygen levels. Okay. So I hope that was we've got enough there with a few beginning ideas that I think we can get into some more specifics of HVAC. So let's do that in the next video.